Hi and welcome. This time around we have an interesting little project involving surface grinders. When I purchased my surface grinder, I purchased the Acer 618-2 as recommended, well, the one that Steve Barton uses. And he does a fantastic job, so I was taking his advice since there's not a lot of information out there about what to get. The Acer is different than a lot of the surface grinders out there, the small ones. And the big difference is that most of them have 1 and 2 horsepower motors. The Acer has a 3 horsepower motor. And as a result, most surface grinders support 1/4 inch and 1/2 inch wheels. The Acer supports up to a 1 inch wheel. This is a 3/4 inch wheel. And the advantage of the larger wheels is that when you dress them, you keep a sharp cutting edge longer. Downside is more materials in contact even when it gets worn a little bit, and so you need a higher horsepower motor to drive it. Well, that takes me to the arbors. So the Acer came with an arbor, and the arbor on the Acer had spacers with it that would allow me to use pretty much any wheel I wanted, all the way up to 1 inch. I bought additional arbors from the vendor, and the additional arbors only came with this really tiny shim. And as a result, they only support 3/4 inch and 1 inch wheels. Most wheels are 1/2 inch or 1/4. The most common, I believe, is 1/2 inch. So what I need to do is I need to make some shims. And when I looked on the wheel that came with the Acer, they did a little bit of relief on the spacers, so I will do the same thing. In order to make my job a little bit easier, I found some round stock that was the right outside diameter that had some material already removed out the center, although you can see that's a pretty nasty looking hole, not even close to round. So we need to bore out a section of that. And we're gonna basically cut off a bunch of these pieces. And the only reason I'm even showing you this project, since it's such a simple project of basically creating washers for the surface grinding wheels, is that number one, it's going to be interesting relief. I've got to cut in each one of these, and the material is kind of interesting. But the real reason is because holding these washers in order to face each side is going to be a bit of a challenge. And the solution I chose was to get a 5C expandable collet holder that you can cut out a inset part for, and I can hold the parts very shallowly on the back of this to face them off. So that's what I intend to do. Actually, this is the 4 inch, and I bought a set from All Industrial. I believe that the 3 inch will be adequate. So what I'll probably do is cut this guy out, and I thought that the machining and using one of these might be useful for everyone out there. So that's what I intend to do. So what I'm hoping, I'm actually going to cut these pieces off in the bandsaw, but before I do that, I want to bore out the centers of them. And the weird part about that is that I really don't want to waste a lot of material. So this is a lot of stick out. I've got to figure out whether I can machine this safely without using a steady rest. What I might have to do, I want to make 5 of these spacers, which is about 2.5 inches worth of material. So if I cut this guy in half, I'll have a little slug behind here, and I'll just cut a bunch of these off, and that probably will be enough in a 3-jaw chuck to hold it safely enough to bore out the center, take it over the saw, cut the pieces off, and then we'll be off to the 5C collet holder and face these guys off. Finally, I am going to take these washers and I'm going to surface grind them because you want them to hold really flat. You want them to be really flat to the wheels so that there's no angle, because that could be a problem. So let's just proceed. Let's head on over and see how. I think I am going to cut this guy in half and just hold it in the 3-jaw chuck. In case anyone was wondering, finding material that had a hole in it already that was even close to the right diameter was quite a challenge. It doesn't seem to be standard material out there. As a matter of fact, I have no idea what this material is, cold rolled or something else. But I was going to have to buy a solid piece, and I didn't relish the idea of throwing out most of it by cutting out the center. So this makes me a little bit happier. since this guy is a dry saw, I typically use cutting wax to aid in my cutting and keep the tooth life up. So this is what I'm currently using. So I've mounted the piece I cut off in the 3-jaw chuck, and I just want to make sure there wasn't any taper, any significant taper. It isn't lying completely flat against the back, and it is a saw cut, so it's not overly accurate. So what I'm going to do is I'm going to face one side, flip it around, reinsert it in the 3-jaw chuck, and then face this side. And I'll have at least one good face for the first part. That'll put me a little bit ahead of the game. And then we're going to bore out the center. Taking a 20 thousandths depth of cut. As long as we're at it, we're also going to clean up the longitudinal face of this just to make them nice. There isn't a specific diameter you're really looking for. What I'll use as a reference is the rough diameter of the arbor itself. Looking at how nice this stuff cuts, I'm thinking it's not cold rolled or hot rolled, but I don't know. .75 thousandths depth of cut, 9 thousandths of revolution. I'd say that time around things were getting pretty hot. This nice blue curly cues here. Not exactly breaking chips, which I would have liked, but even with this high feed rate. And the RPMs are set at about 440. A little surprised, maybe it needs to be pushed harder. Next up, we're going to up the feed rate to 14 thousandths of revolution, about 50 thousandths depth of cut. Still not breaking chips. Last pass, 3 thousandths depth of cut, 2.2 thousandths of revolution. And the finish went to hell in a handbasket. It really wants big bites. I think this stuff sucks. It must be cold rolled. Got the outside cut. Now we're going to do the inside. Start with the 25 thousandths depth of cut. A lot of stick out. This is 25 thousandths and it's only touching in a couple areas. It's kind of crazy. This thing is far, far, far from round. We're going in 7 thousandths of revolution. That's pretty interrupted cut. I thought with 25 thousandths I might be able to bite. So now I've stepped up to a beefier boring bar, and it's a carbide shaft one. So let's see if we get a little bit better results. I was getting some chatter. Hopefully this will prevent it. All right, so we've bored out the center. Here is the arbor, and it is a really tight fit. No wiggle. No wiggle at all. Very nice. So now we go to the bandsaw and we cut a bunch of these out. Next up, 5C collet. We've been working on some layout here. Just putting lines every 6/10 of an inch across here. I want them to be 0.5 wide, so I'm leaving myself 1/10 of an inch for cleanup on each one. And I went ahead and turned down the other side of this on the outside and the inside for that matter, just so that I wouldn't have to fight clamping it. This way the whole thing would be parallel and easy to clamp. Just gonna cut out 5 pieces. And then we'll head over to the lathe. Alrighty, while I'm cutting over there, I'm going to set up the step chuck here. And what you do is, this is a 5C collet with soft jaws here. And some of these, the nicer ones, come with a pin already. This one did not. So I had some 1/8 inch soft stock. And you basically just put that guy in there and then tighten down on it, and that prevents the jaws from closing all the way. You machine out the size you're interested, the dimension you're interested in, and then when you close up after the pin's removed, you'll be able to get your final dimension where you want it. I'm using the ER40 collet adapter here to MT4 that I built the Tang extension for, and we're just going to use a 1-inch end mill and gently go in and try and remove about a 1/4 inch depth. That will make it easier to bore out the remaining. So on first touch, there we go. We're going to zero that guy. This is kind of a big bite. It's bouncing all over the place, so I won't go to full depth or full diameter. I'm going to try out this new boring bar I got from Steve Barton over at Solid Rock Machine Shop. There's their name on the side. And these boring bars are made out of tool steel that are hardened. And they're pretty fantastic. And here's one other advantage of them. If you happen to break an end, they're two-sided. So you don't waste the whole tool if one side goes bad. They're a fantastic deal. I highly recommend them. Head over to Solid Rock Machine Shop and pick yourself up one if you're interested. You get to see it in action here in a second. Comes with one insert. The insert's a premium insert. I forget which brand he said it was, but someone like Mitsubishi or someone like that. Very nice coated insert. So we're going to give it a shot here and see how it performs. I think we're going to go in about 25 thousandths just to try it out here. And that's a heavily interrupted cut. Did a very nice job. So when you can't get your telescoping gauges in here, this is an inside mic. Help you do a shallow hole. Last pass, we're going to clean up the face here. So here's the fit with the pin engaged. Oops, it's, you cannot go in at an angle, it's too tight. There we go. Almost no slop, very, very nice. And now we'll pop the pin out and see how tightly we can hold this part. All right, so now I've removed the pin. And it's already kind of tight. There we go. Well, that's going to hold the part well. I think I was worried that I didn't leave enough material on the outside, but that guy is in there. I made one more observation, and that is that this part's fairly thick, this head. So if I didn't like this part that I did here, I could just face off the rest of this part out here and start a whole new one inside. Also, if I had a smaller part and I wanted to leave the bigger part, I could still hollow out the inside and leave the hollower part, provided I didn't need to get any closer than this would allow. So a pretty versatile tool. First step is I've taken these guys and deburred the edge on one side, and I'm going to put that edge in on the chuck. And I'm going to tighten it down. And even though it's not perfectly flat, we're gonna try and get at least one edge to seat. If it's off, they should be close. They usually are. Come over. Gonna find my 0. Gonna go in about 15 thousandths. Let's do 15 thousandths or so. Square off one side. Still not breaking chips. Pretty high feed, well, 4 thousandths a revolution feed rate, and we're at 1100 RPM. Deburr the inside. And the outside. And just in case that turned up a burr, it's a very nice surface finish. Did turn one up inside a little bit, so I'll have to clean that up, but the outside doesn't have any. So now we're going to take the part, flip it over, which I made this part too close to, I made this 5C step collet too close to size, so it's a bit tight when it's all the way loose, and I probably could have left more slack. I was just worried it was going to end up overall too loose. So I overcompensated, and I think could open it up a few thousandths. It would make it easier to get the parts in and out, but still be able to clamp it very nicely. So anyways, yeah, it's a press fit even when it's all the way open. Let me give a rough estimate here of depth. How about if I flip it this way? Looks like it's exactly 0.525, almost, depending on where I set this. Yeah, there it is. So, let me bring you in a little closer for this one. So let's just make sure this should be seated the same, but let's see where we're at here. If I call that 0, I'm going to go in to get a nice flat surface. We'll go in about 15 thousandths here. Okay. And now we can measure depth. So after it says we're about 0.505. Oh, you know, do I have a, oh, the burr's going the other way. That's good. All right, so we're about 0.505. Before we go back, let's deburr this edge. And the inside edge. And because that's still, that deburring operation turns a little bit of a burr in this material. Take that. Just for the hell of it. Not that this depth is critical or anything, because it really isn't. It just needs to be 0.5 or so. How about that? That's pretty darn close. Oh, sorry. Focus. Alrighty, so I'm going to move on, do the next ones, and I'll bring you back. I almost forgot. We need to put in the relief. So I'm going to go in about 25 thousandths. And I believe about a 1/4 inch or a little more than that around the edge. It's not a particularly important value. Let's see, I could give myself a way to get there. Let's see if I choose, how about there as my 0. The actual dimension doesn't matter. Okay, set my 0, my DRO, so I'll come back out to that, and I'm going to have to reach chamfer the inside because I'm silly. I think that's good right there. We're going to call that my 0. Of course, I had to drag a piece along the face there to scratch it, which is annoying. Okie doke. Rechamfer the inside, and I'll bring it back. I think what would be really handy would be to have a hole in the backside where you could push a pin in to eject the part. If I was going to do more than just a couple of these, I would definitely consider that, because this is a pain. One interesting observation for this hot rolled steel, this was a pass at 680 RPM. My next pass is going to be at 1120 when I'm doing this, and watch the improvement in surface finish. It's kind of crazy fast, really, but it really improves things. Okay, so we're going to go for 10 thousandths. So there's only a 10 thousandths depth of cut, which is also disadvantageous for a good quality finish. Sorry about the vibration there. Something's not quite balanced. So starting and stopping the cut to clear chips is going to cause some lines to appear in it, but it also scratches the surface. But check out the outer portion of this where I didn't have the scratching. Look how nice that finish is. Here, I'll stop it for you. Look at that. It's like glass. Night and day improvement just by doubling the RPM essentially. So I think that might be the trick for this hot rolled steel, and maybe even cold rolled steel, is just go really high RPM and just make sure you use carbide that can deal with it. Because it's really unfortunate, the finish when you go slower. It's just ugly. The 25,000th depth of cut. And you can see how much better that finish is. That is just beautiful. It's such a shame. Anyways, moving on. So since I don't have the wheel going yet, what I'm going to do is I'm going to take this 10 thousandths thickness gauge, feeler gauge from Starrett, and I'm going to put it between the workpiece and and I'm going to lower the wheel down till this just touches. There you go. So here's the part. Beautiful finish on it. It's got a little bit of a sharp edge, so I'm going to flip it over. I'm going to deburr it, flip it over, and go to the other side. don't know if you can see that. That's taking off about 2/10,000ths all the way across. And that cleaned up all the way, so we're just going to go with that. There's the finish, one side and the other side. Here we are at the end here, so here's all 5 of them. This is the plain cutter finish at high RPMs, which is pretty darn good. You can tell where I start and stop the cutter to break chips, since I wasn't getting a chip to break. Then I tried one with the gray Scotch Brite, and that's actually turns out really nice. There you go. And last but not least, the one I surface ground, so it just hit the high spot here and the back here. This is not hardened material, so I think it's hard to get a great finish with not a very coarse. It's a pretty coarse wheel I'm using 46 grit, so it might just be an experience too. So, all right, let's load up a wheel and make sure these fit. Oops. Let's do the 1/4-inch wheel because that's the one that needs the biggest spacer. So then the relief goes in. The release part goes in, and then you tighten this guy down, which you can see there's plenty of threads. Oops. And we're good to go. Alrighty, so this was the 1/4-inch wheel. Here's the 1/2-inch wheel. And I also went and chamfered both sides so that the contact patch for this for the nut would be smaller on the device. So this is the surface ground one, and so now it doesn't matter which end's in. Got plenty of meat, and there's an additional spacer on here that was used for the 3/4 to go between 3/4 and 1-inch wheels, and I could take that one out as well because that one's not really necessary, or I can just leave it because it all fits just fine. So there you go, there's 1/2-inch wheel. So this is the project complete. Hope you find it interesting. Thanks for watching. Hope to see you next time.